Hello, and a very good morning to all of you who've joined in today. So, we're going to start with our executive dialogue 2, and this is going to be around decarbonizing the building construction sector in India. We're going to be talking about this on our platform that's the Feed Event 2022, organized by the Alliance for an Energy Efficient Economy. Please note that we'll be opening the floor for a Q&A session for the last 10 minutes. So the entire audience is requested to please keep posting their questions in the dialog box you see on the right sides of your screen. A very quick shout out and thank you to our sponsors for this event. Our platinum sponsor was Danfoss, our gold sponsor was The Breed, and our silver sponsor was Saint Gobain and Smart Jewels. A big thank you to all of you. This wouldn't be a success without all of you being with us. May I now very quickly introduce our expert speaker for the day. We have amongst us Dr. Thomas Lützkendorf. He's a founding member of the International Initiative for a Sustainable Built Environment and a member of the editorial board of Building Research and Information. Within his research and education work, he's concerned with questions related to the implementation of sustainable development principles within the construction and property industries. Thomas was and currently is involved in the development and testing of sustainability assessment systems for buildings such as BNB, DGNB, and NAWOW. Welcome, Thomas. Over to you.
So, good morning, dear colleagues. I will give you a short presentation, but this is a pre-prepared presentation, so please start this presentation now. So we are missing the sound, dear colleagues. There was a sound close to the slides. So if there is no sound, I will explain you the slides. So namaste, kind regards from Germany. I share the dream with you to achieve a zero carbon India. And I'm here not just to tell you something. I also like to learn from you, from your current activities, but also from your famous politicians and famous economists. You can see this on the slide. By the way, there's one important question. Are the greenhouse gas emissions of the building stock like elephant in the room? It's not so clear what happens with the gray and embodied emissions. So there is a very unclear situation about the share of gray emissions. By the way, around the world, 40% of energy-related greenhouse gas emissions can be allocated to building construction and operation, and 10% out of this can be allocated to construction product industry. In your country, in India, this figure is much higher. I have learned this from the materials I get in front of this session here. So there was mentioned something like 16%. By the way, we must take the right perspectives on greenhouse gas emissions. So first of all, there is a capacity of planetary ecosystem, and using safe operating space and science-based targets, we can create a global budget from greenhouse gas emission. Using the approach of effort sharing, we can have adjusted budget per country or per capita. But now it becomes more important. We can subdivide such a budget to different sectors like industry, in the meaning of construction product industry, in the meaning of real estate industry and construction industry. But in addition, and this is very important to our discussion today, there is something like area of action. You can also call it area of activity, the buildings itself. And there are the areas of need, like housing. And from there, we can go back to the personal budget per capita. To doing so, we have to take into account direct, indirect, and embodied emissions. And we will come back to this later on. By the way, with this slide, I like to show you how this fits together. First of all, we start left-hand side with a macroeconomic perspective on construction and real estate sector. But if we can go down, you will see per year, we have the embodied and greenhouse gas emissions from operation, from refurbishment, from end of life, but also from new construction. From there, we go right-hand side to the life cycle of a single building, again with embodied and operational greenhouse gas emission during the full life cycle. And if we can see above, there is again the personalized carbon footprint per year, and the housing will contribute to this. Right-hand side, you can see situation in Germany. If we follow a cross-sectoral approach in Germany, more than 40% of greenhouse gas emissions can be allocated to the area of action, buildings. And again, also here in Germany, around about 10% are for the gray, so-called embodied greenhouse gas emissions. Now we must describe the landscape. What are our objects of assessment and what are the levels to act? So we have, first of all, a national building stock, the regions, the cities, the neighborhoods, and last but not least, also the individual buildings. Let us take this as an example. For sure, we have to integrate all the actors, like the building owners, the financiers, design and professional consultants, construction product manufacturer, construction company, service provider, and last but not least, also building permit authorities. In our area of action, we have to deal with new construction, reconstruction, and refurbishment. So we can use this as a landscape, and from now we will talk about a single building. In the case of a single building, and this here is based on an international survey of existing literature, you can see the increase of relative and absolute values of embodied impacts. In our days, the share is close to 50% already. And for a zero emission building in operation, it will become close to 100%. So it's not a good idea to ignore the embodied energy, the embodied emissions longer. With this slide, I like to provide you with a short shopping list. To improve the situation, we need a basket out of different things like assessment method, data, the design and assessment tools, and also the benchmarks and target values. By the way, there is an ongoing activity in India to create a national database in relation to life cycle impact assessment data for construction products by one of my colleagues taking part also today. So kind regards to Shiva Kumar. So in the next slide, we will see how we can create a system of benchmarks and target values. For sure, we can start with legal binding limit values. From there, we can go for reference values, but more important, let's discuss for short-term target values like nearly zero greenhouse gas emission and the long-term target value like net zero in the full life cycle. So right-hand side, you can see we have different options to create such benchmarks from point of view of system boundary. And just if we take building-related operational greenhouse gas emissions, user-related operational greenhouse gas emissions, the upfront so-called initial embodied greenhouse gas emissions, and greenhouse gas emissions from replacement and deconstruction, we are able to follow the full life cycle approach. This means the column D. We have to go for column D to create a system of benchmarks and target values. So let me summarize with some recommendations for policymakers. In any case, we need some legal requirements to limit the use of energy, but especially the greenhouse gas emissions in the life cycle of buildings from 2025 or before. I recommend to you to follow a top-down approach from planetary boundaries. But from my point of view, the limitation of greenhouse gas emissions is not enough. This should become a part of an overall approach to protect the environment and to save the resources. And now, public power authorities, I like to invite you to become a front runner. You can use the strategy of green public procurement or sustainable public procurement to show good examples. And at the very end, each company, but also each public authority is invited to come out with a sustainability report to show the progress in limiting the greenhouse gas emissions of the building stock, the institutional building stock, the national building stock, and also in the life cycle of a single building. By the way, examples are already available. If you go to some of your national standards, you can see sustainability management become already a very important topic also in India. And again, thanks to my colleague. So I wish to us a certain progress. Let's make the carbon footprint of buildings, in our case, the elephant, smaller. And in this way, I wish you a lot of luck and a lot of success. And I hand back to the moderator. Thank you.
Thank you so much, Dr. Thomas. It was really insightful to be listening to everything, and it was a very invigorating presentation for sure. Thank you for joining us today here. Very quickly, I'm going to now move into the moderated discussion for the evening. So for the moderated discussion, may I please first invite Dr. Rajan Raval. He's the Senior Advisor at the Center for Advanced Research in Building Science and Energy, commonly called CARBS, and he's also a CRDF professor at the CEPT University. He serves on the Executive Council of AEEE, that's Alliance of Energy Efficient Economy. Professor Rajan Raval has been honored with the fellow status by the American Society of Heating, Refrigerating, and Air Conditioning Engineers, commonly called ASHRAE, in 2020. And he has also been awarded with the fellow status by International Building Performance Simulation Association, that is the IBSA, in 2022, the first ever Indian architect to receive such honors. It's a pleasure to be welcoming you, Dr. Rajan. Over to you.
Thanks, AEEE, for organizing such a wonderful forum, and thanks, Professor Thomas, for providing a platform to discuss some of the important aspects, along with the what many of us are trying to deal with in the building sector. We have wonderful panelists today, and let me introduce each of them at one go, and I'm sure that AEEE team will include them in the streaming. We have Dr. Peter Graham from Australia. Peter is Executive Director and also a very active member in India as far as the work is concerned through his Global Building Performance Network. He is heading GBPN since 2011, but I guess the journey and his connection with India actually started with the work in 2014, and then onwards continuously GBPN is working in India. So great to have you, Peter, here. The second panelist we have Dr. Sunita Purushottam. Sunita ji represents Mahindra Lifespace Developer Limited and is also a board member of GBPN. Since about 20 years, Sunita ji is driving sustainability and environmental consultancy in various forms. She is also passionate about looking at overall environment, not just a GHG emission, but how GHG emission is connected with the air and water, and I'm sure she will be talking about that in a few minutes. She is a physics graduate, and I really admire people having a basic degree in basic science and then they migrate to a real practice. She's having a PhD in environmental science and engineering. Thanks Sunita ji for spending some time with us. We have another panelist, Samir Maithal. Samir Maithal is a founder director of Green Tech Knowledge Solutions. I see Green Tech Knowledge Solution is one of those consulting firm which has a deep root in research. They work on a policy, they work in a practice, they try to change things on the ground as well as they try to change things at the policy. So they have a wide variety of work, and I think they have got success in almost everything which they have done. Samir is sort of a go-to person, at least for me, whenever it comes to embodied carbon. whether it is through manufacturing or through materials. And Samir is also the one, although he's an engineer, but I call him an architect of Eco-Nivas Samhita in India. Thanks, Samir. And then we have Guru Prakash Shastri, leading some of the fantastic work which Infosys is doing since quite some time, torchbearer within the Infosys and outside. How do we really bring the corporate into managing and spreading the message for energy efficiency and GHG emission reductions? So thanks, Guru, for coming here. Guru is a energy engineer, and I think he spends quite some time outside India studying as well. Thank you, all of you. I think the format does allow us to first listen to the experts, panelists, and then we will have a round of questions, either from the audience, or if not, we will discuss things internally. I invite Peter to help us understand some parts which he is working in India and also globally, more on the policy side. Over to Peter. Thank you.
Thank you, Rajan. Namaste. And Thomas, thank you very much also for your context setting. I'm going to share my screen and give an overview here of the policy settings. So let me just make sure that you can see that. Is that appearing on the screen, Rajan?
Not on my screen, at least.
Yes. Well, let's hope that everybody can see the presentation now. So, yeah, I'd like to give you a bit of an overview of policy measures. The challenge that I was presented with in this panel really is to think about how we make a transformation to zero emissions, and with a bit of a focus on the embodied emissions side of things. But the question really is about market transformation. This issue of getting to zero is something which has really landed as a, let's call it a mainstream narrative since COP26. And, you know, with good reason. 2019 was the year where we saw greenhouse gas emissions from the building sector at their highest ever level, around about 13 gigatons. And about 3.5 gigatons of those emissions were from the embodied emissions, the elephant in the room, if you will. And so there is a lot of momentum heading in the direction of increasing emissions rather than decarbonisation. The magnitude of this challenge has been set out by the Marrakesh Partnership for Global Climate Action, which was reinforced through the Buildings Pavilion at the COP. We have to halve building sector emissions by 2030 in order to be on track to contribute to achieving a less than or a 1.5 degree global warming target in accordance with the Paris Agreement. So there's a lot to do. And on the embodied energy side of things, we can see at least 40% needs to be reduced by 2030 and 50% on leading projects. So that is a big challenge. And we're dealing with an industry which is really optimized to maintain the status quo. And so we need to be thinking about policy measures which aren't just sort of good in theory, but can actually be implemented through policy transformation and reform strategies. So the way we like to think about it with the work at GBPN is about integrated policy strategies, looking across the whole building life cycle. And I'm going to elaborate a little bit on some of these, but just to show that even though this is a massive challenge, we really do have some clear sight on policies which work. So this is the good news. But really, very fundamentally, we need to have a clear perspective of the goal. And what's encouraging when we see what's happening in India at the moment is that setting of a zero emissions target is driving a series of new initiatives to be able to achieve that and transform the economy towards zero. But without the target, without the ambition for zero, then we don't see any of this transformative change. Many countries are making commitments and developing policy strategies now. So we can see, for example, just do a quick tour of the world. China has established this 1+N emissions peaking strategy. for which the building sector plays a really important role. Decarbonising the building sector is really one of the key measures in the 1+N peaking strategy. And again, you can see a number of things which are going to influence the whole value chain and construction market, from setting a carbon, incorporating the building sector into the carbon market, through to a focus on reducing emissions from new construction by 90% by 2050. We were involved in supporting some of the work of Vietnam and Cambodia in developing their NDC roadmaps. And both countries have identified dealing with embodied emissions as well as energy efficiency in buildings as key components of their NDC, of achieving their NDC commitments. So there's a real awareness now of just how important the whole life cycle, tackling the whole life cycle of emissions in buildings is. The European Commission has just recently, back in December, released a proposed recast of the Energy Performance in Buildings Directive, where they shift the goalposts from near zero energy to zero emissions buildings. And so this is really shifting to that life cycle view. And this is just part of one of the goals from the proposed amendments to the EPBD, that as of 2027, whole of life cycle warming potential of new buildings with a floor area greater than 2,000 square metres needs to be calculated and disclosed, with a requirement for all buildings from 2030. So that, if that were passed, that would really be a transformative signal to the market. Indonesia also incorporated emission reduction targets in the cement industry in its NDC, and of course the building sector on the demand side has a strong role to play in being able to, or enabling Indonesia to achieve its NDC goals. And of course, even yesterday with the announcements from President Modi, we see again an emphasis on market transformation in India and some really strong opportunities for being able to incorporate policy strategies within some of these market transformation initiatives to drive towards the zero emissions goals in India. So that all sounds really amazing. One thing about commitments, though, is that they're easy to make, but implementation is a lot harder. And this is really where we also need to focus from the bottom up on how we enable implementation. Now, this slide just shows that we may be talking about circular economy or zero emissions. We might be using net zero, a whole range of terms which have made their way into the building industry. But actually what we're talking about in terms of the knowledge is really, you could say, ancient, how to use resources efficiently and how to put resources to their highest and best use. And just some examples on the screen here of different approaches to low carbon building construction and design, from recycled bricks and thermal mass in good space planning in school here in Sweden, the use of fly ash concrete panels in a project in the United States, recycling materials in houses, and also recycling materials from outside the building industry in a house in London. The great story of interface and product innovation to provide for recycling there, and even in India, upcycling. With projects that have been looking at how to reuse materials in the local value chain. But fundamentally, when we think about making these reforms happen, the implementation aspect, we're talking about people, and we need to be thinking about the designers, the architects, the engineers, the construction workers, who need to change what they do when they go to work tomorrow. And so a people-centered approach is really key here, understanding who is it that needs to make the changes happen. So finally, again, just to give an overview, we do promote this idea of an integrated policy approach. And when we're thinking about strategies for driving market transformation, we want to look at the supply side policies and the demand side policies together. So this work from Agora Industry from Germany, looking at the issue of decarbonisation of supply chains, sort of points that out, that key things that need to be in place is in a design for integrated policy that's going to work. A carbon price, having government interventions like carbon contract for difference, where there is a risk sharing from the government in terms of carbon pricing, enabling green financing with methods of common standards for accounting for embodied energy and disclosure, labeling of materials, and so on. That also leads to improvements in international trade and being able to set regional standards as well. But of course, then you've got the demand side as well. And part of what we're trying to do now with the work of GBPN is to look at how we can incorporate things like regulatory reform in building codes to enable these new low carbon materials, low carbon concrete, steel, and so forth, paints and other things. How we can enable the use of recycled materials and so on. So there's quite a lot of work that we can do to translate across and create that demand side. And also, I think there's one thing left to say, and that is about design innovation and the role of the private sector. This diagram is a very old diagram from the work of Stuart Brand in '94, looking at how buildings are layers of change. Different layers have different lifespans, and to be able to optimize the connections between those layers and optimize the materials in those layers to make sure that there is a longevity and contribution to circular economy is important. And therefore, we have solutions, but the key to it is really being able to design not just the policy strategy, but the implementation pathways. So just to summarize some of these key enablers: carbon pricing, very important to set the signal for internalizing the cost of carbon. Common standards, disclosure and labeling to support financing and regional trade, regulatory reform, and importantly, anti-dumping, making sure that there isn't green concrete, for example, isn't just a product line, but actually something which is only available in a market. Life cycle assessment inventories and having good access, open access to life cycle data is really key. And this is really important because we have a digital revolution going on in the construction industry right now. And so being able to incorporate this data into digital design tools, e-procurement, supply chain management systems, and e-compliance is really key. But at the end of the day, as I mentioned before, we need to reach out to the people who do the change on a daily basis. And so there's a huge demand in technical support, training and capacity building, with a focus on directly supporting the developers and the builders to change practices in profitable ways. And really lastly, supporting the private sector champions. Some of the really big organizations that are making pledges to zero carbon have huge leverage in supply chains. And so where government policy can support those private sector champions to transform their supply chains, we're going to see those economies of scale and that market transformation occur. So last thing, it's all possible. It's a great challenge, but we know what we need to do. We know how to do it. We've just got to get on and do it. Thanks, Rajan.
Thank you, Peter. May I request Saritaji to share her thoughts?
Yeah,
Saritaji,
sure.
if you can present, or we can ask AEEE team to share
That
this.
will be awesome. If yeah, AEEE.
Shirish, can you just share the presentation? Thank you. Yeah, it's on the screen, please.
Okay, awesome. So I'll also begin with a namaste. I think we Indians are forgetting namaste. So namaste to everybody and a very good morning. And yeah, so representing a private developer, would like to highlight today, what are the challenges for decarbonization or moving towards low carbon economy, so to speak. So the buildings and construction sector, it's a major source of greenhouse gas emissions. And though progress has been made in putting building codes, green building certification, and some amount of investment, the progress has been slow. And that's where it is a little worrying. So net zero by 2050 will require buildings and the construction sector to decarbonize 3 times faster over the next 30 years versus the previous 30. And with rising population and more people moving into urban areas, we expect around 2.4 trillion square feet of new floor area to be added to the global building stock. And that's equivalent of adding an entire New York City to the world every month for 40 years. And India's two-thirds of the building stock that exists today, still needs to be built. And therefore, there is an opportunity here for decarbonization across the globe, as well as definitely in India, to achieve zero emissions from the new building construction, definitely, and also focusing on the existing building stock. And these have to be energy efficient, they have to be climate responsive, and so that it is a zero fossil fuel building. And these buildings have to be powered by 100% on or off-site renewable energy. The challenges are, do we have that infrastructure currently in place? And what are the steps that each one of us should be taking? And along with all of that, what we have to look at is the embodied carbon in building materials, which is a major concern, the elephant in the room. Materials like concrete, steel, aluminum, widely used in this sector, are the major contributors to embodied carbon emissions. And the widespread use of RCC in buildings is also leading to thermal discomfort, which leads to increased use of air conditioning and adding to energy usage and emissions. And therefore, should we look at reviving some of the traditional ways of making buildings and staying thermally comfortable? Historically, Indians and Indian buildings have not used air conditioning in spite of this being a hot tropical country. And climate responsive, region specific architecture revival in design can contribute to a significant reduction in building energy consumption as well as embodied carbon through use of local materials. However, we are still witnessing a gap in the climate responsive design knowledge and its implementation. And while these measures have been well described in green building codes and standards like ECDC and Economar Samhita, these standards are not yet mandatory and have not percolated into the local building bylaws. Additionally, policy incentive on adoption of low carbon materials, GST benefits on alternative low carbon materials, that is an evolving area. And while we have the target to achieve net zero through renewable energy, uniform grid renewable policy procurement across the state is still a challenge. Additionally, on-site renewable is a huge challenge, especially when it comes to rooftop area, space constraints, and other services that need to go onto rooftops. So looking at a mix of small wind, possibly biogas, and on-site solar, and building integrated PVs could also, be some of the solutions that we can look at. But all of these increase the capex significantly. Overcoming that is therefore a challenge for most developers. Buildings have a life cycle impact on environment from construction to occupancy to demolition. And the construction and demolition waste has to be brought up in context of the decarbonization, because currently, while we have the CND regulation rule in place, the processing in India of CND waste is up to only 1%. Rest ends up in landfill or on land and water resources, leading to other issues such as flooding. And therefore, bringing up to the next slide that I wanted to talk about, the interlinkages. So there are positive interlinkages of decarbonization, and if decarbonization is not done well, there are negative interlinkages as well. Air and air emissions, which is the toxic pollutants that we look at, are totally linked to the same fossil fuels that we burn that lead to GHG emissions. But what we have to be very mindful while we talk about the decarbonization and alternative or biogenic fuels, because biogenic fuels also lead to air emissions, and therefore emission control, the pollution control of these biogenic fuels also has to be thought through. So these are some of the SDG interlinkages that I wanted to bring out. And, if we have carbon emission reduction, we can also look at enhancing SDG 15, which is life on land, because if we do the plantations right, it can result in biodiversity revival at that location and in the vicinity, leading to enhanced life on land. So it has a direct correlation of ensuring that reduction through plantation. The plantation, therefore, cannot be, in unidirection in nature with only one species. It has to be local. It has to be native. It has to be in conjunction with the habitat that is there in the vicinity. You can't have afforestation on grassland because that is typically a grassland. And therefore, what are the linkages of your development with that grassland so that we don't lose the animals' movement across your land? So these are very, very holistic. You look at carbon emissions and you say, oh, you have planted 10 eucalyptus trees. Please, that doesn't work because was eucalyptus native? What was the native species? Birds and other animal species, mammals, will not visit if the native species are not there. Climate action, linkages, responsible consumption and production, these are definitely other SDGs that will get positively impacted through energy efficiency, through the demand reduction mechanisms, through the renewable energy integration, leading to sustainable cities and communities, while we look for affordable and clean energy. And it's symbolic that this SDG actually has a sun and a button over there, because we forget the sun and we look at only the button when it comes to getting energy within our homes. The sun is a source of energy. It is also how you design your home, and therefore climate responsive design can enable you to get a good sun into your home while keeping away the heat during the long afternoon hours. Clean air and clean water and sanitation is deeply linked and the resource conservation around water is deeply linked to decarbonization. And you will wonder how. Because getting clean water into your homes is a result of a lot of pumping that happens, getting it from a source which is far, far away into your homes. And what if you were to design homes which is water resilient, has source of water, you're reusing all of water and also ensuring water conservation? So that is definitely something that needs to be thought through. And therefore, one must look at moving away from the carbon tunnel vision. And this photograph is out there in LinkedIn, and everybody is using that. But I must talk about the Panchamrit. And one of the things that the Prime Minister has mentioned is about the conscious consumption, that each one of us are part of reducing the demand, then moving over to energy efficiency, and then going to renewable energy. So these are the two main things that I wanted to discuss today. Thank you.
Thank you, Sunitaji. May I request Samir to share his thoughts and expertise? Yes, Samir, its screen is visible. You are on mute.
Yeah. So, Rajan, can you hear me now?
Yes, we can hear you. We can see
Okay,
your
fine.
screen.
Yeah, sure. So I think the background has been set in terms of the framework which we are talking about in terms of decarbonizing the building construction. And I would like to essentially give you a few examples from India and try to take this discussion forward. So as we have heard that the whole life carbon of buildings, it consists of many components. It consists of upfront carbon, that is the carbon which is associated with the raw material mining, its transportation to the manufacturing site, the manufacturing of the materials, then transportation to the building construction site, and the construction and installation. So that is what we call as upfront carbon. Similarly, we have the use stage embodied carbon, which is related with the maintenance, repair, replacement, refurbishment. And a very large component is then the operational carbon, which is related with the operational energy use. And these two combined together, we call as phase two or use stage carbon. And then we have the end of life carbon, which is then related with the deconstruction, demolition, its transportation to the waste processing factories or sites, and then waste processing and disposal. So essentially, the whole life carbon consists of all these components. And yes, we can express this in terms of kilogram of CO2 equivalent per meter square of the area of the building. As Sunita has also mentioned, this is one aspect which is related with the carbon emissions, but then we can have other matrices as well, which are related with other environmental impacts, which may be related with the ozone depletion potential, or the photochemical ozone creation potential, or acidification potential. So this is just to mention that while we focus on the carbon footprint of the buildings, there are other environmental impacts also about which we should also be concerned about. Now, the two examples which I am going to present, the first one is the whole life carbon assessment of net zero energy building at Karlsruhe University. This is work done under a master's thesis by Millie Jain under guidance of Rajan. And they have tried to calculate the whole life carbon for this particular building, which is a very well-known net zero energy building in India. So if you look at the upfront embodied carbon for this particular building, which as in the previous slide I explained as phase one carbon, what one can see is that there is a very high contribution of cement, steel, as well as solar photovoltaic panels. So we have to be mindful that solar photovoltaic panels also, which we are using for net zero energy building, are also contributing to the upfront embodied carbon. When they calculated the entire whole life carbon for this building, the net carbon impact came to almost 2,600 tons of carbon dioxide equivalent over 60 years lifetime of the building. So there is a net carbon impact, as well as what we have to see is the lifetime of the building is also an important parameter while we calculate this whole life carbon for a building. And then if suppose that has to be offset, they estimated that 60% increase in solar PV generation capacity would be required to offset these 2,600 tons of carbon dioxide. So one thing which we have to see is that the net zero energy buildings doesn't necessarily means net zero carbon buildings. Generally, when we are talking of net zero carbon buildings, then we will have to do much more compared to net zero energy buildings. And in India, we still have very few net zero energy buildings. So I think we have to properly look at this challenge of how to go towards net zero carbon buildings. The other assessment which I would like to present is a work which was done with Ashok Bilal Architects, Japan Shah Structural Engineering Consulting Company, and our office. Essentially, we were looking at a typical urban construction, which is very common in India, wherein you have on a piece of plot 3 or 4 story residential construction which is done. And we wanted to see that how the impact of different types of structural systems and building materials would have an impact on the upfront embodied carbon assessment. So this is not the entire whole life carbon assessment, but we are only looking at the upfront embodied carbon, which, as we have seen, is a very significant part of the whole life carbon assessment. And in this particular case, we have considered 5 cases. And these are combination like where we are also looking at. So here, essentially, the case 1 is the concrete frame construction with ordinary solid bricks, which is the most common or baseline construction in India. And then going forward in terms of resource efficiency and having case 5, which is the sort of most resource efficient, is vertically cored hollow block confined masonry with waffle slab. And what we could see here is that by moving from case 1 to case 5, almost 50% reduction in upfront embodied carbon is possible. That means, like for the baseline case, if we have estimated that the upfront carbon is almost 280 kg of CO2 per meter square, and then that can be reduced to almost 140. Now, in the process, what is happening is not only we are reducing the upfront carbon, there's almost 65 reduction in the quantity of steel used, almost 50% reduction in the amount of clay used for making the blocks. And similarly, there is a significant reduction in the cement quantities. And also, this system is also almost 50% cheaper in terms of structural cost. So here we can see that there could be a win-win case here where for certain type of building typologies, we can have alternate systems which helps us in reducing the carbon as well as are also economically cheaper. So just to conclude, the first point, net zero energy building doesn't necessarily mean net zero carbon buildings. In the Indian context, I think we have to develop better understanding of phase 1 and phase 3 for different typologies of buildings. And as I said, that primary analysis suggests that we may have solutions which can help us in reducing upfront embodied carbon, and which may also be sort of win-win solutions. Thank you.
Thanks, Samir, for bringing up what's happening on ground. It's very helpful. Over to Guru. I know Infosys has a huge repository of data, and they keep churning out the data for their internal purpose. And many times they also provide insights into how they're managing their sustainability targets. I'm sure Guru has a lot to share. Over to Guru. Thanks.
Yeah, thanks, Rajan. Excellent talk by the previous speakers as well. And from the user point of view, I would like to mention three points which I feel is very important when it comes to the building and construction sector. The first point is of course, I am talking more specifically on the ITES sector because that's what we have a lot of data on, and that's what I've been working on for the last 14 years almost. So when it comes to building and construction sector with this particular IT buildings, the first important point is to have clear building performance metrics. Of course, this applies to other sectors as well, not only IT, but when it comes to buildings, I would feel it's very important to define clear performance metrics for buildings. Why I say this is because there are a lot of buildings that we see, green buildings and certified buildings and so on and so forth, but nobody knows whether it's really efficient or not. The certification is not really what we are looking at, right? We are actually looking at driving down the demand and energy consumption. So I'd like to share a few just a second. I'd like to share a few slides on what I think is important in terms of building energy metrics. I hope you can see my screen. Is my screen visible?
Yeah, Guru.
Yeah. So when you look at the performance metrics for buildings, see today the problem we have is when you are looking for an efficient building, you don't know what to specify, right? That's the common problem everybody faces. In fact, even when we look at renting some of the space in some parts of the city, when we talk about any performance metrics, nobody has a clue. The owner, the builder, usually doesn't have a clue. And look at what the standards that we follow. These are typically about one third of what the industry follows, the building industry follows, or specifically the commercial buildings follow. So there is a huge scope for improvement here. Unless we have clear, simple metrics for buildings defined, it's very difficult for people to understand and select wisely in terms of low energy buildings or high performance buildings. That's the first point. The second point, and this is also very important from the design aspect, because you look at some of the electrical demand numbers. We have 3.3 watt a square foot. That's the peak demand, including everything in our building, right? That's what we design for. A typical builder is at 7 to 10 watts a square foot, which means every single equipment in the building is oversized by 2.5 to 3 times. So when you know that it's going to be an office building, then why design 2 to 3 times oversized? So this is a complete national waste, right? You are spending extra on equipment. You are actually buying equipment which is not required. So that's a very important thing. The second important point is the use of technology. Today, we do have a lot of tools available. Sorry, which can help you optimize the building design so that you know what kind of building energy performance that you will have, and how to size your equipment in the building appropriately. So this is something available today, which not many people have made it a part of their design process or operations process. Um, but if you see, at least in India, different sectors, when you look at the industrial sector, there's industrial automation is far more advanced, right? And when you look at automobiles, there is a huge advancement that has happened. But unfortunately, in the building and construction sector, the advancement is very, very minuscule in the last 2 decades, right? I mean, how many people are using a good simulation model to simulate the structural design, to optimize the structural design, and the amount of steel used in the building, the amount of glass to be used in the building? Very few people do that, right? People still go by convenience and ease of getting things in the market, rather than the holistic view of a life cycle of a building. So this becomes very important: use of technology, use of the right tools, not only in the design but also in operations. So this is some examples of what we have done in terms of operations, because um, it's not enough just to design the building on a high performance metric. It's very essential to maintain the performance over a long period. So typically buildings are designed for at least 20 years, 25 years. So how do you ensure they are running as efficiently as day one? So this is only possible through continuous monitoring with reliable sensors, reliable energy meters, and so on, right? And this is what we have done across Infosys, and this we feel is very important because this has saved us a lot of energy, operational energy over the last decade, and also helped us in identifying opportunities for savings in our existing buildings. So we've been able to reduce some 35 megawatt of connected load. So we have surrendered a large part of our contract demand with the discoms in many of our locations. Only possible because we know what we are consuming, where we are consuming. You can only manage what you can measure. So that's definitely what we believe. And today there are enough building automation systems available. And if you know what to specify, what to monitor, if you define a clear metrics, then you can really utilize the automation systems in a very, very effective way. Today, a lot of automation companies, I'm sorry to say, but they are just interested in showing you some screens where you can switch off, switch on things remotely. But that's not really the ultimate purpose of any building automation system. They can be used to manage your overall operations in a much, much better way. And we have seen that in the last decade plus at Infosys, and we have really been able to utilize the automation systems in a very, very effective manner. The third point I would like to say is how this aligns with the ESG goals. Today, you hear a lot of companies taking up ESG goals. Even we published our ESG commitment a year and a half ago for 2030, that we would continue to be carbon neutral across all emissions until 2030. But one thing that we have to be very careful when we define this ESG vision, specifically on the environment, is it's very easy to jump to renewable energy or carbon offsets, which is a very easy path to offset all your emissions. Because today a lot of people are talking about emissions, right? So there are easy paths available to achieve zero emissions. But the first and foremost very important step is energy efficiency when it comes to net zero emissions. The first is energy efficiency. Drive down your demand, drive down your consumption, operations, energy, and then invest in renewable energy. And whatever is remaining after that, those are the emissions that need to be offset. So these are the steps to be followed. And this needs to be made more in terms of more aware publicly. And a lot of companies today, especially IT companies, if you see, a lot of companies globally have taken up some ESG goals, very aggressive ESG goals. And I feel if we don't follow this process or this approach of energy efficiency having the first and top priority, then the whole point is somewhat lost. We are still having a lot of energy consumption happening, still having a lot of emissions due to that, but we are offsetting. And if we are depending on renewable energy, we are adding unnecessary capacity on
Guru,
renewable energy
Guru,
plants.
Guru, can I request you to conclude in 30 seconds from now?
Yeah, this is all what I wanted to say. So this is the third point. So I feel there is a lot of opportunity, and look forward to working with all experts like you guys to make this happen at a policy level and so on. Thank you very much.
Thanks. Thank you, all of you. We have a couple of questions, but let me first. Peter has one question for Sunita ji. So, and Peter can unmute and ask question directly to Sunita ji. Peter, over to you.
Yeah, thank you. Sunita, I must admit I was a bit shocked by this. I think I might have heard the statistic 1% of C&D waste is recycled in India. And I noted that in the announcements yesterday, there was a sort of double down commitment to circular economy. It seems like a big opportunity being missed, perhaps. And I'm wondering whether it's got to do with building design, buildings not being designed to be deconstructible, or whether it's to do with, or whether that's improving. I'm just wondering, if we're going to decarbonize, we definitely need to be dealing with the end of the pipe and the circular, encouraging.
Yeah. Yeah, Peter. A very small fraction gets pushed back into the construction sector. The reason being, one, the C&D waste rules and the implementation of the same, the infrastructure that is supposed to be put in place for C&D waste is now being put in place. Okay, so there has been a lag of putting that infrastructure in place. The other challenge that is there is how many of these infrastructures do we require? Because the reason being that if you have a development which is happening, say, in the outskirts of the city, where is the infrastructure located, and where would a developer want to, would they be required by the law to put it over there, and what is the monitoring mechanism? So that needs to be put in place, because what happens is most of the local community could actually take the construction and demolition waste, because a lot of land is getting developed. Now, why I'm saying local community, because as roads get expanded, the trees get cut. The trees get cut and shops come up. And the C&D waste is lined up along those. And I'm seeing this. I'm seeing the kind of development that happens along the sides of the road as the peri-urban areas of the city get developed. So, would the local authorities and the municipalities take up this to close the gap between what's actually happening on the ground with respect to C&D waste? And a lot of development that's now going to happen in India is redevelopment. So that's the other challenge. The redevelopment means if I have a 4-story, 5-story building, I will pull it down and redevelop it with higher FSI. So these are going to be high rises, more compact. But the earlier development that was there will generate a lot of C&D waste. So what do you do? What is the mechanism over there? So that also needs tightening. So it's a huge opportunity space, and I'm seeing very interesting players come in, and we can discuss this in much detail. But it's a very exciting space, and I've seen the other side of the story, the opportunity space also, where I've seen plants work at very high efficiency, completely environmentally friendly mechanism to generate aggregate and engineered sands. So that's very interesting, and I'm very glued into that development area of
Great,
C&D
thank you.
and circular economy.
Thank you so much, Cindy.
Thank you, Sunitaji. Thank you, Sunitaji. I think for the perspective of time for everyone, probably we can conclude this session. Is that fine, Jayanta, AEEE team? Any comments? Any concluding comments or procedure we need to follow? Over to Afsha. Thank you.
Yes. Thank you, Dr. Rajan, and thank you to everyone who's joined in for this executive dialogue. Just before we conclude, I'll very quickly like to extend my thank you to our networking and outreach partners who helped make this entire event such a big success. So a big shout out to Griha, Ishre, Rama, and the India Smart Grid Forum, which is the ISGF. What I'd like to tell all of you is that now we are going to break up until 11:40, and then we are going to enter our next sessions. So parallelly, we are hosting 2 executive dialogues. One will be the executive dialogue on transforming the experience of Indian energy consumers through digital technology. And the second one is going to be around mainstreaming energy efficient and low energy cooling appliances to achieve thermal comfort for 1 billion lives, powered by SIF. So for all of you interested to listening to any one of these dialogues, please go back to your lobby, through your auditoriums, log into any one of these sessions. See you all at 11:40. Thank you.